Hi, I am Geet Shehran from Computer Science and Technology degree program. I am going to do a tutorial on simulated tool available for logic gate based implementation. Let's go. First, we want to download simulator tool. I will download Logism for design the logic gates. So you can download Logism throughout this website. Click the download button and download it. I already downloaded it. When we open Logism, we can see canvas area on our right side. It's the built-in area, and you can see top of this area. We can see some tools and basic logic gates, and we can get all the logic gates under the gate folder. You can see all the logic gates you have access to. If you want to work with some logic gate, you can drop it and drag onto the working area. We can label their input and outputs. First I will get NOT gate. This is the NOT gate. I will give output and input, and this is the input and this is output. After that I can label the outputs and inputs. I label the input named X and output is Y. So after that we can run this gate. After that we can give true value and false value for their inputs. So you can see if input is true, the output will be false, and input is false, output will be true. We can get the truth table of this gate through analyze circuit and go to table, and you can see here the truth table. If you want to copy this truth table, you can select all and copy onto the Word or Excel file. In here you can see the input is false, the output will be true, and input is true, the output will be false. Now I will get AND gate. This is the AND gate. I drag it and drop here. So after that I can give inputs and outputs and labeled their inputs and outputs. After labeling, I can give true value and false value for their inputs. You can see here, if one of input is true, the output will be false, and both inputs are true, the output will be true, and both inputs are false, the output will be false. After that I can get their truth table. You can see here all the values are true, all the input values are true, the output is true, and one of input is false, the output will be false. This is OR gate. I will design it. So I can give their inputs and outputs. After that I can label their inputs and outputs. So in here you can see one value is true, the output is true, and both values are true, the output will be true, and both values are false, the output is false. So in here also we can see their truth table by throughout analysis circuit. Let's go there. In here you can see one of input is true, the output is true, and both inputs are false, the output will be false. We can create another two basic gate with combining NOT gate named NO and NAND. So NO gate can be created through combining O and NOT gate, and also NAND gate can be created through combining NOT and AND gate. So NOT gate gates in output are opposites to O gate output, and NAND gates output are opposite to AND gates output. So in here you can see the truth table of them. There are more two basic logic gates. One of them is XOR. So in XOR, when we input same value, the output will be true, and when we input different value, output will be false. And other one is XNOR gate. So when we input different values, we can see through value for output, and when we input same values, the output will be false. Here you would see the truth table also. Now let us connect a lot of gates and create a new basic circuit. So I am creating a circuit. I will get their input and output. After that I will label them. So after that we can see their output how changing, and we can see the truth table, and you can understand it. So how the output depends on the inputs. The simplest way to make any basic signal bit set, reset, SR flip flop is connect together a pair of cross coupled 2 input NAND gate as shown to form a set reset disable, also known as an active low SR NAND gate latch. So there is feedback from each output to one of the another NAND gate input. This device consists of two inputs, one of called set capital S, and another called called the reset capital R. So with two corresponding output Q capital Q, and its converse or complement Q, not Q R, as on this example. So the set state, and it's consider the circuit shown this example. If the input R is at logic level 0, R equals 0, and input S is logic level 1, S equal 1, the NAND gate Y has at least one of this input at logic 0. Therefore its output Q must be at the level logic 1 NAND gate principles. So output Q also feedback to input capital A, and so both inputs to NAND gate capital X are at logic gate level 1, and therefore its output Q must be at logic level 0. Again, NAND gate principles. Okay, and if their reset input R change states and goes high logic level 1 with S remain high also at logic level 1. NAND gate Y input R, now R equals 1 and B equals 0. Since one of these input is still at logic level 0, the output at Q still remain high at logic level 1 and there is no change of state. Therefore, the flip-flop circuit is said to latched or set with Q equal 1 and Q equals 0 and the reset state. In this second table state, Q is at logic level 0. Its inverse output at capital Q is at logic level 1 and is given by capital R is 1 and capital S is goes to 0. As gate X has one of these input at logic 0, its output Q must equal logic level 1. Output Q is feedback to input B, capital B. So both inputs to NAND gate Y are at the logic 1. Therefore capital Q equal to 0. If the set input S now change state to logic 1 with input capital R remain at logic 1, so output Q still remain low at logic level 0 and there is no change of the state. Therefore the flip-flop circuit reset state has also been latched, uh, and we can define the set reset action in this. The decoders and encoders are designed with logic gate such as an OR gate. There are different type of encoders and decoders like 4, 8 and 16 encoders, and the truth table of encoder depends upon particular encoder chosen by the user. Here 4-bit encoder is below in explained. Along this the table, the 4-bit encoder allow only 4 inputs such as A0, A1, A2, A3 and generate the 2 outputs like as F0, F1 as shown the example. Normally encoder has a number of inputs line among which one of these is activated as given time, while encoder has more than one input which is activated based on encoder. So which means that encoder are used to control interrupt equent by action conducting to highest request if 2 or more inputs are equal to 1 at the same time. So the input having highest priority and will prefer to take internal hardware will check this condition and priority which the set. This encoder and decoder are designed with logic gate such as AND gate. So there are different type of decoders like 4, 8 and 16 decoders, and the truth table of decoder depends upon particular decoder chosen by the user. Here about 4-bit decoder and its truth table. So 4-bit decoder allowed only 4 output such as A0, A1, A2, A3 and generate two outputs of two output F0, F1 as on this example. Here we get an example by 2 to 4 line decoder. In this type of decoder and dedicates decoders contain two inputs A0, A1 and four output responding by D0, D1, D2 and D3. So as you can see the truth table, for each output combination one output is activated. In this example you notice that each output of the decoders is actually returned recently from contain outputs combination. So that is D0 equal A1 A0 which corresponding to output 0 0 and D1 equal A1 A0 which corresponding to input 0 1, D2 equal A1 A0 so which corresponding to 1 0 and D3 equal to 1 A0 which corresponding to input 1 1. The circuit is implemented with AND gate as on this example. In this circuit the logic equation D0 is A1 divide A0. So on through each output of decoders will be generated to the input combination. Another is digital logic circuit in electronics that is extensively used for the addition of numbers in many computers and other type of processors. Adders are even used to calculate address and related activities and calculate table in indicates in the ALU and even utilized in other parts of the processor. So these can be built for many numerical representational like X, XS3 or binary code decimal. So adder are basically classified into two types. One of is half adder and other one is full adder. The half adder circuit has two input A and B. We can name it switch and two input digit and generate a carry and sum. So the full adder circuit has three input A and C switch add three input numbers and generate carry and sum. I named there by the example. So this example gives details information about what is the purpose of hard adder and full adder in the tabulate form, even circuit diagrams too. It's already mentioned the main and cursive purpose of adders is addition. So below the example half adder and full adder theory. So let's go in half adder. So coming to the scenario of half adder, it's at two binary digits where the input bits are termed as argand and addend and the result will be two output, one of the sum and the other is carry to perform the sum operation. XOR is applied to both the inputs, and gate is applied to both output of pursuit carry. So there is the full adder circuit is at 3 one of bit number, where two of the three bits can be referred to as operand, and the other is term is bit carry id. So the product of the product output is 2 bit output, and this can be referred to as output carry and sum. By using half adder, you can design simple addition with the help of logic gate. Let's see an example of adding two signal bits, and here you can see the truth table of this. As the full adder, this adder is difficult to implement compared to half adder. It's different between a half adder and a full adder is that the full adder has three inputs and two outputs, whereas half adder has only two inputs and two outputs. The first two inputs are A and B, and the third input is a carry as C in. When we full adder logic is designed, you string 8 of term together to create a bits wide adder, and cascade the carry bit from the adder to the next. So here also you can see the truth table of this full adder. Subtraction is arithmetical function where one digit is subtract of another digit to uh, attain equal quantity. The digit from which other digit is to be subtract is known as minuend. Similarly, the number which is subtract from the minuend is known is subtrahend. Sum is to the binary addition. This also include four feasible alternative operation where each subtrahend bit can be subtracted from the uh, minuend bit. So however, in the second rule of the second rule, bit of minuend is lesser compared the bit of subtrahend. Therefore, one is on long to complete the subtraction related to the adder circuit. This circuit also categorized this like half subtraction, full subtraction. So let's move to the next part. In half subtractor. So the combinational logic circuit like half subtraction is used to subtract two single bits, yeah, it includes two input as well as two output. The input is capital A, capital B, uh, whereas the output are borrow the difference. Please refer this example and the truth table. uh, you can know more details about the half subtraction. In full subtraction, the combination of logic circuit like half subtraction is used to subtract two single bits. It includes three input as well as two output. The input are A, capital B, and bin, whereas the output are borrow and difference. You can refer this example and logic gate, truth table for the about the full subtraction. Therefore subtraction include the uh, capability of excuse the 3 bit subtraction by taken into consideration of the borrowing in the lower signal stage. You can refer these examples for more get more information. Multiplexing is the generic term used to describe the operation of sending one or more analog or digital signal over a command transmission the line different times or speed, and as such, so the device we use to do just is called a multiplexer. So the boolean expression for this 1 to 4 to 1 multiplexer above, with input A to D and data select line A B is given as. So Q is equal simple A, simple B, A plus, and simple A B, capital B plus, simple A B, capital C plus, simple A B and capital D. So in this example, at any one instant time, only one of four analog switch is closed, connecting only one of the input line A to D to the signal output is output at Q. So as to switch is closed depend upon the addressing input code on line A and B. So for this example, to select input B to the output at Q, uh, the binary input address would be to be simple A, logic 1, and simple B, equal logic 0. So uh, this we can show the selection of the data through the multiplexer is a function of the data selection bits shown as. So then we can see the multiplexer switch in circuit that just switch or route signal through themselves and being combination circuits. So they are memorialized as there is no signal feedback. Both the multiplexer is a very useful electronic circuit that has used in many different applications, so as signal routing and data communication and bus control application. The data distributor, known more commonly as common as a demultiplexer, or demux for short. It's the extra opposite of the multiplexer we show in the previous example. And the multiplexer takes one signal input data line and then switch it to any one of number of individual output line one of a time, and the demultiplexer converts a series data signal at the input parallel data at output line as shown this example. So in here also we can see a truth table like other example. In the logic and computing, a counter device which stores and sometimes displays the number of times particular event or process and occurred, often in relationship to a clock. The most common type is a sequential digit logic circuit with an input line called the clock and multiple output lines. Now let's see, we will see 3-bit counter, all the flip connected by clock signal. I will connect some clock signal. I will label them named T0, T1, T2. So T0 is always 1 and we want to to input and add and logic gate. After that we want to connect outputs of them. So now connection I saw. So start the enable, see the output here. Output is you can see like 001, 010, 011, 100, 101, 110, 111. This is the counting. This sequential device loads the data present on inputs and then move or shifts its to its output one every clock cycle. Here's the same shift register. A register basically consists of several signal bits, D-type data latch. So one of each data bits, either a logic 0 or a 1, connected together in a serial type DC chain at arrangements. So that's the output from the latch becomes the input of the next latch and so on. We connect D flip flop gate and give inputs and outputs and also clock signal. So after that we can see how output depends on the input signal. You can see the output will continuously shifting.